Okay, problem 10.17. Consider the functions f is e to the x squared minus x squared minus 1 and g is the integral of f from 0 to x. Write a Taylor series of g in powers of x. Okay, so let's first expand f in the powers of x. We have, this is the sum from n equals 0 to infinity, the series of the exponential x to the 2n divided by n factorial, right? X squared minus x squared minus 1. So this is the first two terms, right? So this is, let's say, this starts at n equals 2, right? And one way to rewrite this starting from 0 is the sum from the n equals 0, and this is x at 2n plus 2, right? 2n plus 4. Okay, so the first term is going to be x to the 4th, right? And this is n plus 2. Yeah. Now the integral of this, g, is the integral of f from 0 to x. Now so as we have done before, the integral of a sum is the sum of the integrals, right? Right, and this is true because the series converges absolutely everywhere in the real line. Okay, so we don't have to care. And now we have this integral, right? This is the sum from n equals 0 to infinity of, and this is g to the 2n plus 5 divided by 2n plus 5 times n plus 2 factorial, right? Evaluated at x and minus 0, but at 0 is going to be 0, and then x is going to be x to the 2n plus 5. This is the Taylor series of g. Okay, now b, determine if g has a maximum, a minimum, or an inflection point at 0. Okay, so let's see where the first terms, right? The first term when n equals 0 is that x is x to the 5 divided by 5 times 2, x to the 5 divided by 2 plus small o of x to the 5, right? When x is close to 0. Now what x to the 5 is a polynomial that does something like this, okay? And it has an inflection point at 0, so g has an inflection point at 0.